study about the free electrons theory. So the unit 2 name is free electrons theory. So in this unit we will discuss about the conducting materials. Okay, so mostly free electrons is nothing but what is the, so it acts as a conduction process. Okay, free electrons நாலே ஒரு conduction process தான் வந்து அதோட functioning வந்து it acts as a conduction process. Okay, so here now we will study about the free electrons theory never considered solid materials. Okay, so generally we will taken as one of the metal, we will taken as one of the metal, any one of the metals, solid material, conducting materials இருக்கும். So இந்த never considered metals என்னன்னா number of electrons இருக்கும், or the number of atoms, the arrangement of the atom, one of the perfect solid materials, the number of arrangement of the atoms is present in our considered solid material. Okay, so in this particular solid materials la atoms irukku. So the atoms full enna irukum, electrons irukum. For example, this I will consider one particular atom. So center la nucleus irukum, nucleus sutti enna irukum, orbitals irukum. Okay, so the number of orbitals irukum. So this orbitals in mele enna irukum, so electrons is placed. Electrons is placed in our considered orbit. So depending on the material base pani number of electrons வந்து it should be changed. Okay, so here the outermost orbit one particular electrons வந்து definitely it should be present. Okay, so depends on the material base pani number of electrons வந்து change ஆயிடும். Okay, and then here so this outermost orbit electron is called as we call that this is the free electron. The electron என்ன சொல்றோம், so that electron is called as a free electron. It ready to start for the conduction process. Okay, so it எப்படி வந்து bell அடிச்சோனே last row boys வந்து first வெளிய போறாங்களோ அதே மாதிரி வந்து எப்படி சொல்றது, so நம்ம ஒரு conduction electrons, the free electron is nothing but it ready to start move for the conduction process when we apply some electrical field. Okay, ஒரு field apply பண்ணும்போது இது உள்ள இருக்கிற electrons எல்லாமே covalent bondல bond ஆயிடும். Okay, outermost orbit இருக்கிற electron தான் first layer. Okay, so this particular electron when we apply some electrical field, so this electron it first start to move for the conduction process. Okay, so that is called as, so that particular electrons na outermost electrons na we call as free electrons, or it is called as the valence electron அப்படின்னு சொல்றோம். Okay, so இந்த free electrons எல்லாமே எங்க இருக்குன்னு பாத்தீங்கன்னா it is present at the conducting materials. Mostly conducting materials la number of free electrons, நிறைய free electrons வந்து ஒரு conducting materials இருக்கும். Okay, so that particular free electrons நால current conductions நிறைய இருக்கும். So that conducting material, so conducting material வந்து எப்படி சொல்லலாம், it is also called as the low resistivity material. And the resistivity வந்து கம்மியா இருக்கும். So the low resistivity material is also called as the conducting material. Okay, so in this free electrons theory we discussed about the classical theory, quantum theory and the band theory. So classical is one of the macroscopic theory and quantum is one of the microscopic theory. So band theory is the study of the energy bands. Okay, energy band of conduction and valence band we discussed. Okay, so here, so in this classical theory இருக்கட்டும், quantum இருக்கட்டும், energy band theory இருக்கட்டும், எல்லா இதுக்குமே நம்ம என்ன ஸ்டடி பண்ணுவோம்னா free electrons பத்தியா. So motion of the electrons. So electron oda motions illana endha applications me illandradha. Okay, one of the conducting material okay, so adula now we will discuss about some postulates. Okay, in this particular unit la 3 important 60 marks irukku. Totally I think 560 marks. So the major 3 important 60 marks, the one that is comes from the classical theory, another one is the quantum theory, and the last one is the band theory. Okay, so now we will discuss about the classical theory. Classical is one of the macroscopic theory. Okay, so in this classical theory na first we will discuss about the postulates of the free electron theory. Okay, postulates of the classical free electron theory. adula nama வந்து first discuss பண்ணும்போது first postulate, the postulate number 1. So postulates 1 la வந்து it will taken as one of the conducting material. Okay, ஒரு conducting materials எடுத்துப்போம். In that particular conducting material la the field is not equal to, field is equal to 0 and the field is equal to 0. ஒரு field ஏ நாம கொடுக்கல, ஒரு conducting materials இருக்கும். Inside of this material all the electrons, because நிறைய free electrons இருக்கு. Okay, so all the electron it is random, it is moves in random directions. எல்லாமே எப்படி இருக்கும்னா it should be moving in random manner or random directions ல மூவ் ஆகும். ஒண்ணுக்கு அந்த எலக்ட்ரான்ஸ் எல்லாமே இடிச்சிடும். ஓகேவா, சோ அப்ப வந்து lattice elasticity வந்து அந்த collision process நடக்குது. Okay. So due to this presence of this random motion, so all the electron is transferring the energy and also get the lattice elasticity of the collision process வந்து ஏற்படும். ஓகேவா? So field 0 ஆ இருந்தாலும் அந்த மெட்டீரியல்ல kinetic energy தான் இருக்கு, potential energy இல்ல. In our considered conducting material. நான் சொல்றது conducting material பொறுத்த வரைக்கும் எப்பவுமே வந்து அங்க நிறைய free electrons இருக்கும். So due to the presence of free electronsனால without applying the field 0 ஆ இருந்தாலும் எல்லா electronsமே வந்து randomஆ இருக்கும். It having some particular motion that so that's the reason it have the kinetic energy. So here the potential energy is 0. So in this particular consideration it obeyed the kinetic theory of gases னு சொல்றாங்க. இந்த process வந்து என்னன்னா kinetic theory of gases வந்து obey பண்ணுது. Because we will consider as one of our container. ஒரு container எடுத்துக்கலாம். Inside of this container we will fill some gas molecules. Gas molecules fill பண்ணிருக்கோம். ஓகேவா? So the gas molecules எப்படி இருக்கும்? அப்படியே dissolve ஆகுமா? It's getting dissolved. So என்ன ஆகுது? அங்க ஒரு random motion of the molecules தான இருக்கும். Now we consider the container we will fill some gas molecule. So the motions எப்படி இருக்கும்? the molecules or the ions எப்படி இருக்கும்? It is getting the random motion, no? So in the same way, when we apply without applying the field, all the electrons in our considered conducting material, all the electrons are moved in random directions and also having the lattice elasticity. So due to the so in this process is nothing but it looks like a gas molecule. It looks like a gas. ஒரு கண்டெய்னர்ல இருக்க gas molecule எப்படி இருக்கோ அதே மாதிரி electrons எல்லாமே randomஆ ஒன்றுக்கொன்று மூவ் ஆகி it's collide each other னு சொல்றாங்க. Okay. So that's the reason. So this particular electron it's obey for the kinetic theory of gases. The kinetic theory of gases. ஒரு கண்டெய்னர்ல இருக்க gas molecule வந்து என்ன பண்ணுது? It obey the kinetic theory of gases. Okay. So in the without applying in the field of the electrons, so this electrons is also it obey the kinetic theory of gases. Understood? The point புரிஞ்சுதா? ஒரு gas molecules எப்படி இருக்கோ அதே மாதிரி அந்த ஒரு without applying field 0 ஆ இருக்கும்போது அந்த electrons எல்லாமே random motions வருது. So it obey for the kinetic theory of gases. Understood? Any doubts? Doubts இருக்கா? Okay. So next one is when field is not equal to 0. Okay, when we apply some field, the field goes. Okay, when field is not equal to 0, this is our considered material. This is our considered material, and this all the electrons are moving in regular direction. Okay, periodical arrangement. Okay, when field is not equal to 0, when you apply some field, the field so all the electrons. So this is the field directions. So all the electrons is nothing but when you apply some external electrical field inside of this material the electrons, all the electrons are nothing but it is moving opposite of towards the field direction. Okay, periodical இங்க எப்படி ரேண்டமா மூவ் ஆகுது, இங்க எப்படி periodical arrangement இருக்குதுல்ல. So here the current conduction is produced. Okay, so already வந்து அது ready to start conduction ல தான் இருக்குது. ஒரு ஸ்லைட்டா நம்ம ஒரு ஃபீல்டோ ஒரு டெம்பரேச்சரோ கொடுக்கும்போது என்ன நடக்கும்னா the material it act as a conducting process அப்படின்னு சொல்லுவோம். Understood? Understood? Field கொடுக்கறனால the current conduction produce ஆகுதுன்னு சொல்லுவோம். Understood? புரிஞ்சுதா புரியலையா? Understood? So this is the another point. உங்க bookல கூட கொடுத்திருக்காங்க பாருங்க. In the absence of the electrical field, all the electrons moves in random direction. This moves in random direction. But when we apply some electrical field, all the electrons are moving towards or opposite to the field directions னு சொல்லிருக்காங்க. ஓகேவா? So இங்க வந்து நமக்கு drift velocity ஆட் பண்ணுது. Listen now. For example, when the electron is moving from one point to another, point level இன்னொரு point electrons வந்து move ஆகும். I mean when we apply some electrical field, electron it is moving towards or opposite to the field direction. No. அப்ப இங்க இருக்க electron ஒரு direction க்கு move ஆகுதுன்னா, which having the velocity no, and velocity இருக்குமா, motion of the electron க்கு. So definitely இருக்கும் and also it having the periodical arrangement தான் இருக்கும். Okay. So எல்லா electronமே ஒரு particular directions ல மட்டும் தான் move ஆகுமே தவிர randomஆ இருக்காது. When we apply some electrical field கொடுக்கும்போது ஒரே directions ல தான் எல்லா electrons move ஆகும். So that's the reason this particular velocity is called as the drift velocity. So when velocity is called as what is that? Drift velocity and also dv. That is the average velocity acquired by the free electron in a particular direction. Okay, well, in a particular direction. When the electron it can be moving in one particular direction. So that velocity is called as the drift velocity. Understood? So drift velocity na any doubt in this drift velocity? So here, next one is the mobility. So mobility is nothing but it is represented by mu. Mobility is represented by mu. Okay. So here the drift velocity. Drift velocity is due to the presence of free electron. Okay. So drift velocity due to the free electron pair unique electrical field is called as the mobility. So mobility mu is equal to Vd divided by E. Okay, our drift velocity per unit electrical field is called as the mobility. So mobility is represented by mu again. So understood? Any doubt in this step? Any doubt? Clear? So now we come to the expression for the electrical conductivity in terms of the mobility. Clear? So I will consider this. This is our considered rod. We take it as this is our considered rod. So in this considered rod, when you apply some electrical field, listen now. Listen now. This is our considered rod. I think all are studying this too.
Yes, ma'am.
Okay, so this is our considered rod. So in this considered rod, the number of electrons is present. Okay, the number of electrons is present here. So this rod or a length is nothing but L. Its area is nothing but represented by capital area, and also this inside of this considered material, the number of electrons is present here. That is represented by small elements. Okay, so here when you apply some electrical field, here the current conduction is produced in this considered rod. So this is general thing. Now without applying the field, we will take it as only that the rod. Field without listen, without applying the field, we will write that the total number of electrons. Total number of electron in solid. Total number of electron in solid material. Total number of electron in solid material is nothing but that is capital N. Total number of electrons in the considered rod to the net number of electrons. So the total number of electrons in solid material is represented by capital N. So capital N is equal to number of electron, that area of the cross section, and then that particular length of the material. Understood? Understood or not? Okay. So the total number of electron in this solid material, capital N is equal to NaL. NaL. Okay. So this is the equation 1. Understood? Understood in this step? Okay. Total number of electron in this solid material. Next is total charge in solid. Okay. Total charge in solid material. So that is Q. Total charge present in the solid material, that is represented by Q, is equal to N into total number of electron into charge of 1 electron. Charge of 1 electron means charge of 1 electron. So this is the first equation. So what we write, Q is equal to N into minus E. Okay, so Q into N into minus E. Minus sign is represented by an electron. It is moving towards or opposite to the field direction. So you have to put here minus sign. Okay. So here, this is the equation 2. Equation 2. Next, now substitute this term. This is the equation 2. Substitute equation 1 in equation 2. So what will get here? N is equal to what will get here? Sorry, Q is equal to total charge. Q is equal to what will get here? NaL into minus E. This is the third equation. This one is what is the third equation. Understood up to this here? Last one, boys. Understood? Understood or not? Listen here. Next. So now we conduction process. So electron is getting some motion. So when drift velocity produced. Okay, so what you write here? So the current produced ஆகுது. So the current passing through the solid. Okay, and the current in solid material. Current in solid. Current in solid material I is equal to total charge. Total charge per unit time period. Per unit time taken for the charges, motion of the charges. Listen here. So here now when we apply some field will know current conduction of the produced cycle. Okay, so both the current produced in the solid material. So the current produced cycle is not current produced cycle due to the motion of the material, motion of the electrons. Motion of the electrons. So definitely it having some drift velocity and act under. Yeah. So the current in solid is equal to I is equal to total charge divided by time taken for the movement of the charges. Okay, motion of the charges. So the time period T. Okay, so now I is equal to Q divided by T. So this is your fourth equation. Okay, so now substitute equation for equation 3 in equation 4. Substitute equation 3 in equation 4. So what you get here? What you get here? So I is equal to N A L minus T divided by T. Small t. So this one is the fifth equation. This one is what is the fifth equation. So now write the formula for the current density. The current density is nothing but it is represented by J. Current density is represented by J. J is nothing but is equal to flow of current per unit area. So the current density J is equal to flow of current I divided by area. So I divided by area. I divided by area. So now substitute. This is the sixth equation. Now substitute equation 5 in equation 6. So what will get here? J is equal to N A L into G divided by T divided by A here. So now J is equal to N A L E divided by T. So denominator into 1 divided by A. So here cancel panilama. A cancel. So what we get here? J is equal to N L minus E. And then cancel panila next is right here. J is equal to N L into minus E divided by T here. Okay. So here L by T is what here? L by T is what here? L by T is nothing but it's a drift velocity. E is equal to what is that? L by T. So it's the drift velocity. Okay, L by T is the drift velocity. This is the formula. So substitute here. Substitute here in this portion. So what is right here? So J is equal to N into VD into minus E. So this one is the seventh equation. This one is the seventh equation. Understood? Up to this clear? First equation? Area of the cross section. Here, this is
the area of the cross section is the area of
this is the per unit area formula. This one is. Okay. So this is the formula of mass. Listen now. One second. Current density formula is nothing but one of our solid material current density flow of current per unit area. Okay. So here one of our solid current density na solid material current density. So our definition is flow of current passing through the solid material per unit area is called as the current density. So the current density J is equal to I divided by A அப்படின்னு சொல்றோம். அந்த ஃபார்முலால நம்ம அப்ளை பண்ணி இங்க cancellation. Understood? Here? Okay. So now come to the Ohm's law. So here current density in terms of Ohm's law. See here current density in Ohm's law. In Ohm's law, so I is equal to V divided by R. I is equal to V divided by R. This one is the ninth equation, and then R is the resistance. Resistance is equal to rho into L divided by A. This one is the 10th equation. Listen now. Okay, 8, 9. Okay, now. Listen now. So here I is equal to V by R. It's the Ohm's law, and R is the resistance. Resistance is nothing but resistivity is produced in our considered material is called as the resistance. Okay. So resistivity na enna to resist the flow of current da nam resistivity சொல்லுவோம். So that is represented by rho. Okay. So அப்ப வந்து ஒரு current flow வந்து தடுக்கிறது தான் resistivity ன்னு சொல்றோம். இல்லையா? So அப்ப அந்த particular resistivity process ஒரு மெட்டீரியல்ல நடக்குதுன்னா that is the resistance அப்படின்னு சொல்றோம். ஓகேவா? So அததான் இங்க சொல்லிருக்காங்க உங்க புக்ல டெஃபினிஷன்ஸ் இருக்கு பாருங்க. Opposition offered by the solid in metal. Opposition offered in metal for the motion of the electron கொடுத்திருக்காங்க. ஓகேவா? So in our considered solid material mention பண்றதுனா it is taken as the resistance. Yeah. So that's the reason resistance is equal to rho into length of the material divided by the area of the cross section of the material. Understood? Definition pura. Okay. So now substitute. Listen. Now substitute equation 9 in equation 8. Substitute equation 9 in equation 8. So what will get here? Substitute panna. R is equal to what will get here? Not R. Sorry. I is equal to P divided by rho L divided by 8. So next term enna kedukku namukku I is equal to VA divided by rho L. Understood in this step? Understood? Okay. So the next term V by L is what ma? V by L is what here? Next, not V by L. Now take the current density formula. What is the formula for the current density? J is equal to I divided by A. So this one is the 8th, 9th. This one is the 10th equation. Now substitute equation 10 in equation 6. Current density la substitute panna. What will get here? So here J is equal to VA divided by rho L and then divided by VL. So here J is equal to VA divided by rho L into 8. So here the cancel பண்ணலாமா? A is cancel here. So J is equal to E divided by rho L. Okay. So here V by listen now. V by L is what ma? V by L is nothing. V by L is nothing but it's the electrical field. Applied electrical field is equal to voltage per unit length. So that is V by L here. And then sigma is equal to what is that? 1 by rho. Sigma is what is that here? Conductivity. Conductivity is nothing but it is inversely proportional to the resistivity. So substitute. Up in V by L rho is also there. So we have right here J is equal to sigma into E. So this is the equation. 11th equation. Understood? Any doubt in this step? Any doubts? Shall I rub this side? Salama. equation 11. Okay. Compare equation 7 and 11. So what will get the 11 equation is equal to 7. So sigma into E is equal to, because here also J is equal to sigma into E, and here also J is equal to N into minus C. So equating these two equations, so what will get here? Sigma E is equal to N into PV into minus C. Okay. So now what you'll find out here, the question is when find out from sigma. What you'll find out? Sigma. So sigma is equal to N into VD into minus E divided by capital E. Okay. So now mobility term is what is that? Mu is equal to VD divided by A now. So substitute here. So what we get here? Sigma is equal to N into mu into minus E. Okay. So this is the equation for the electrical conductivity in terms of mobility. Understood? Any doubt in this test? Any doubt in this step? Okay, so this question is that this one is an important 10 to the 8 to 12 marks question. So the FP raise out of now state the postulates of the classical free electron theory. So that time we have to write the three statement. One statement and the so already I explained one field is equal to 0, all the electrons are moving in random direction. So we have the kinetic energy is present, and also we have the next step. Okay, the next step. So that's why having the lattice elasticity. It acts as the lattice elasticity. Next, when the field is equal to 0, we have it at the random direction. So it looks like a gas molecule. So it obeys the kinetic theory of gases. That is the second point. When we apply some field all the electrons are moving towards or opposite to the field direction, and the member it acts as the current directions. So this one is the third point. இதுக்கப்புறம் drift velocity நீங்க எழுதிக்கலாம், mobility நீங்க எழுதிட்டு அந்த definition totally 5 points write out பண்ணனும். After completed the 5 points you write this equation steps. ஓகேவா? So இந்த questions எப்படி raise out ஆகும்னா derive the expression for the electrical conductivity in terms of mobility. Listen, in terms of mobility. ஏன்னா நம்ம upcoming topicல திரும்பியும் expression for the electrical conductivity பார்க்க போறோம். அதை நீங்க கன்ஃபியூஸ் பண்ணாதீங்க. In terms of mobility வந்துச்சுனா you have to derive in this step. இந்த ஸ்டெப் தான் நீ derive பண்ணனும். In terms of mobility. Okay? Understood? Completed? Any doubt in this step? Any doubt? Any doubts, ma? What, ma?
I is equal to V by PL அது வந்து VA by PL மாறுது.
ஆமா.
அதே வந்து J is equal to VA by
J is equal to I by A.
I by A. அதுக்கு J is equal to
VA divided by rho L.
by A இருக்கு. ஆனா A வந்து கேன்சல் பண்றீங்க, ஆனா அது மட்டும் A க்கு கேன்சல் இல்ல. அந்த ஸ்டெப் அப்போ பார்த்தா VA ஸ்கொயர் டிவைட் பை rho L அப்படி வரும். அதான் என்ன rho
wait. Rho L into so 1 ega. So 1 divided by A. Okay, va? Understood? Step okay, va? So kilo 1 ega. So மேல multiply பண்ணும்போது நாம 1 divided by A ஆகும். So you now cancel this one. Understood? இல்ல
அந்த தண்ணி மேல அந்த I அது போடுவோம். I is equal to V by PL by A.
I is equal to
P by A by A. மேல 10th step மேல அது அது வந்து A வந்து PA க்கு DA by PL அதுவும் A by 1 தர போடுறீங்களா? VA by PA வந்து ஒரு டிவிஷன்
E divided by rho L divided by E. A வருடா A divided by B divided by A divided by rho L A divided by okay understood okay then any other doubts students any other doubts this side completed this side Pavitran Indriya listen now listen. So now we will discuss about the next question. So the expression for the electrical conductivity. Okay, so the electrical conductivity is nothing but the amount of charges flowing through the material per unit area, per unit time, per unit electrical applied field. Okay, so that is called as the electrical conductivity. So நம்ம previous topic பார்த்த மாதிரியே same story தான், பட் ஆனா வந்து கொஞ்சம் இங்க வந்து நம்ம வந்து calculate about sigma. Okay, sigma red நம்ம find out பண்ணுவோம். Sigma is nothing but that is the conductivity, electrical conductivity. But in our previous topic la in terms of mobility சொல்லி நம்ம calculate பண்ணிருக்கோம். Question la mobility அப்படி வந்துச்சுனா you should write that the previous derivations தான் எழுதணும். So this is the expression for the electrical conductivity. Okay, so here as it is same material is considered as one of our solid material. When we apply some external electrical field here, so all the electrons are getting some motion, having the periodic arrangement motion is moving towards the field directions. Okay, so that's the reason here the current conduction is produced within the conditions. Understood? Same our previous lecture concept தான். So இங்க நம்ம என்ன பண்ணிருக்கோம், டைரக்ட்டா நம்ம வந்து current density ஓட equation find out பண்ணியாச்சு. Current density find out பண்ணோமா இல்லையா நம்ம previously J is equal to m into dV into minus E. This is your first equation. Next வந்து now we should calculate about the drift velocity. Okay, so drift velocity எங்க, due to the motion of the electron is getting some motion and the periodical regular it is moving at one of a particular direction. ஒரே directionல electrons travel ஆகுறதுனால when we apply some field and the drift velocity is produced. Okay, so due to the presence of drift velocity தான் நம்ம find out பண்ண போறோம். Okay, so drift velocity find out பண்ணனும்னா you should know about what is acceleration, because வந்து அந்த velocity இருக்குனா definitely it having some acceleration also. Okay, so divided by T அப்படின்னு எழுதியாச்சு. And now dV is equal to A into T. dV is equal to A into T. So this is the second equation. Okay, so in equations la அப்படியே இருக்கும். Now we come to the third point here. So when we apply some field, if field கொடுத்தனா என்ன ஆகும்? Electron is getting some motion. How it will get in motion? Because அங்க ஒரு force produced ஆகுது. ஓகேவா? So ஒரு field கொடுக்கும்போது அங்க ஒரு forces produce or internal ஒரு force produced ஆகுது. So due to the presence of force நால electron is getting some motion. ஓகேவா? So you have to write here force experienced by electron. So what you write here? F is equal to minus small e into capital E. So electron is getting some motion. எதனால motion நடக்குது? Due to the producing force நால, presence of force நால தான் it getting some motion. So F is force experienced by the electron. F is equal to minus E into capital E. Okay. So this is the third equation. This equation, third equation. Now we will write the term of the Newton's second law of motion, that is mass into acceleration. Force is equal to what is that? Mass into acceleration. This is your fourth equation. Okay, so you got to stop.